Hey guys, so welcome to our first real lesson on trigonometry. So our objective is understanding the ratios of the sides of right triangles. So I want you to pause the video and do the do now. That's what we've been working on the last few days. So remember I told you for simplifying, I'm going to do it right there. So write down every pair of numbers that multiply to 72. 1 times 72. 2 times 36, 3 times 24, 4 times 18, 5 doesn't go into 72, 6 times 12, 7 doesn't work, and 8 times 9. Then we're going to go through and we're going to circle every perfect square we see. So 1, 4, 9, and 36. So I'm going to pick the pair that is the greatest perfect, is the biggest number. So 36 is the biggest one. So a lot of kids will pick 4 or 9, so be really careful. So I'm going to rewrite 72 as 2 times 36, root 2 times root 36. Now I don't know the square root of 2. It's some weird decimal, so I'm going to rewrite it. But I do know the square root of 36. The square root of 36 is 6. And then to make it look nicer, we're going to put that 6 in front. And that is our simplified answer. Now, rationalizing the denominator. The whole idea here is to get rid of the square root that's in the bottom. We don't like that there's a square root down there. So to get rid of a square root, we just multiply it by itself. But because we have a fraction, whatever we do on the bottom, we have to do on top. 4 times root 3. Now you're not allowed, that's not root 12. You can't, like that 3, it's like a box. It's stuck inside. So that's like us, right? The 3 has coronavirus. It's not allowed to come out. But both of these have corona. They're both under the root, so we're allowed to multiply them. We can put people with coronavirus together. So for root 3, and then, but the square root of 9 we know, right? There's a solution. They got better. The square root of 9 is 3. And then we check, can I simplify the 4 and the 3 from the top and the bottom, like these two? Check if you can simplify. I can't, so I'm done. All right, so trigonometry, what the focus of this is really actually similar triangles where we have right triangles. So look at this picture. This was similar to a quiz problem that we had. Are they similar? Well, they have the same right angle, but do we need to have another angle though? So remember, 90 plus 40 is 130. Subtract that from 180. And we get 50. So that means this missing angle here is 50. So are these similar? They are, because we have the 90-degree angle and then 50 and 50. So this is a yes. AA. So the reason I bring this up is there's a relationship between the sides when you have right triangles. So there is a relationship between the ratio of the sides of right triangles and their angles. If you know the ratio, you can find the angle. If you know the angle, you can find the ratio. So these are similar right triangles. So there's a relationship between, if I have that 4 over 5, right, if I turn that into a fraction, there's a relationship between the angle A and the 4 and the 5. There's a relationship between the 8 and the 10 and angle X, right? X and A are equal. The 8 over 10 equals 4 over 5. So these are the 3 trig ratios: sine, cosine, and tangent. So this is just something that we're going to memorize. It's going to be weird at first, but we're going to be able to do it. Sine of the angle always equals the opposite side over the hypotenuse. Right? So when we say opposite, I mean opposite side, hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So now you see this funny angle, right? That's a theta. It's a Greek letter. And it's really, really common. It's a really common letter to use when you're talking about angles. So, for example, if I have sine of theta, let's put some numbers in here. So I'm going to just pick some numbers. Let's say it's 6, 8, and 10. So that works for Pythagorean theorem. So sine, what is opposite of theta? Well, opposite of theta is the 6. What's the hypotenuse of the right triangle? 10. So that's what we're going to be doing here, right? So write these down. This is just like your notes that you're going to go off of, okay? All right, so here's our example. So it's really important to pay attention to what the angle is. In this case, in every single problem, we're talking about angle A. So here's angle A. So instead of theta, we're using A. We are going to label our triangle, right? So the three things that we need to label are opposite, adjacent, and hypotenuse. So who knows the hypotenuse? Well, the hypotenuse, remember, is always across from your right angle. It's your C value. So this is our hypotenuse. Opposite means opposite the angle. What side is opposite angle A? This side is it's a cross. Opposite is a cross. Okay. So this is our opposite. Adjacent just means next to. What is the side that is next to angle A? So even the hypotenuse is technically next to it, but it's really talking about the legs, the two non-hypotenuse sides. So this is our adjacent. Okay? So sine is opposite on that previous slide. Go back, rewind if you need to. Sine is opposite over hypotenuse. So the opposite side was 8. The hypotenuse was 17, and we're done. That's our answer. We're just writing a fraction. It's a ratio. Cosine is the adjacent over hypotenuse. What's the adjacent side? So that was the 15 over the hypotenuse was 17. And then tangent is opposite over adjacent. Opposite over adjacent, the opposite side is 8. Adjacent side is 15. And that's it. We are just writing down these ratios. All right, so I want you to pause the video and try this one on your own. Start by labeling. So for the labeling, we're looking at angle P, right? So the angle we care about is angle P, and that's important. So to label, I've got my opposite. What's opposite angle P? Angle P across from, that's your opposite. Our hypotenuse is across from our angle, our right angle. And then adjacent is whatever is left over. Right? It's the side that's next to, not the hypotenuse, the other side that's next to it. So sine is opposite over hypotenuse. So 7 over 7 root 2. Now we can actually simplify that. That's 1 over root 2. What do you notice? Remember back from when we learned that our lesson on Monday, we're not supposed to have a square root in the denominator. So now I'm going to rationalize. So my answer is root 2 over 2. All right, cosine. Cosine is adjacent over hypotenuse. That's also 7 over 7 root 2. Notice we get the same answer. So I'm going to cheat, and I'm just going to put root 2 over 2. And then lastly is tangent. Tangent's adjacent over, opposite over adjacent. 7 over 7, which equals 1. So notice sine of p, cosine of p. We had to rationalize our denominator, and that is why we had that lesson. All right, pause the video. I want you to focus just on sine theta, cosine theta, tan. Start with your thetas. All right, so I'm going to label my triangle. So opposite is my hypotenuse, opposite the right angle. Opposite theta, what's across from theta, and then adjacent. So we've got our sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan, opposite over adjacent. So keep that in mind. So sine is opposite. The opposite side is root 3 over the hypotenuse 2. Cosine, adjacent over hypotenuse, that's 1 over 2. And tan is root 3 opposite over adjacent. But now they give us this other letter. So this letter is same idea. This one is called alpha. That letter is called alpha. It's actually A in Greek. Okay, so now if we're going off of that one, things are going to change. Because if we're focused on that angle, our hypotenuse is the same. However, what's the opposite side now? Opposite is now the 1. Okay, I was trying to write hypotenuse by accident. Right, opposite, adjacent. So really pay attention to which angle, because it just changed, right? Our opposite and our adjacent switched. So the blue, I should have kept it blue. I don't know what I was thinking. So with theta, our opposite is root 3, but with alpha, our opposite is 1. So that's going to change our answers. So sine of alpha from alpha, opposite 1 over hypotenuse 2. Cosine of alpha, that's adjacent, root 3 over 2. And tan of alpha is 1 over root 3. But notice again, just like that last one, the previous slide, we now have a square root in the denominator, which we're not supposed to have. So we're going to multiply our top and bottom by the root. Root 3 over root 9, which is root 3 over 3. And that's our answer. All right, last slide. Now this is a little harder one. This is about as hard as we can get. All right, so now look at this picture and tell me the problem. We are missing a side. We do not have this side, sad face. So we need to find it. Think back. How do you find a missing side of a right triangle? Pythagorean theorem. A squared plus b squared equals c squared. So I'm going to do a squared plus 2 root 15 squared equals 14 squared. Now, our last lesson, that last slide, I went over how to do this specifically because of this lesson. So we have a squared plus 2 squared is 4. Root 15 times root 15 is 15 equals 196. So that's a squared plus 60 equals 196. I'm going to subtract 60 on both sides. A squared equals 136. Take the square root. A equals the square root of 136. 136 can be simplified. I know, it's a lot. 136, 1 times 136, 2 times 68, 3 doesn't work, 4 times 34, and so notice the 4. So this is the square root of 4, square root of 34, 2 root 34. So that one's kind of hard, right? That's a rough problem. All right, so now let's highlight our angle. So we're going to start with angle theta, and let's label it. Hypotenuse is always the same. Just going to put an H. Opposite, and then this one's adjacent. So sine is opposite over hypotenuse, 2 root 34 over 14. I can divide the top and bottom by 2 to simplify. Root 34 over 7. Cosine, adjacent over hypotenuse, 2 root 15 over 14. So that's root 15 over 7. And lastly, tan, 2 root 34 over 2 root 15. Okay, I'm going to cheat. I'm not going to finish this one because I don't really want to multiply 15 and 34 together. We should rationalize this, but that number is ridiculous. It's going to be a big number, so I'm just going to leave it. I'm going to be a bad math teacher. Sorry, bad math teacher. All right, same thing. Now with alpha. Let's do green. Alpha. All right, so this time this is my opposite. This is my adjacent. My hypotenuse stays the same. So opposite, 2 root 15 over 14. And the nice thing about these, we literally have the answer. We did this already. Root 15 over 7. This one's going to be 2 root 34 over 14, which is root 34 over 7. And then tan, 2 root 15 over 2 root 34. So root 15 over root 34. So notice there is a relationship here. Again, this one's really, really hard, right? This is the tough problem. This is for like my 95 plus students, right? To be able to do this. My expectation is I would not make this one this hard on like a quiz, right? That's it. Do your homework. It's due on Friday. If you have to bring questions for Thursday, we will chat some more about this. Have a fabulous day, guys.